In this lecture, we are going to learn about logical operators. Now, logical operators are used for combining expressions. Let's say you are supposed to make a decision, or you are supposed to write a decision making statement, and you are supposed to take a decision based on multiple conditions. So if you have to take decision based on multiple conditions, there you will have to use logical operators. So to understand this, let's take some example. The first example says that you are supposed to write an expression to check if the number is divisible by 2. So number x must be divisible by 2. So how do I check for divisibility is, I divide the number x by 2 and check the remainder. So x mod 2 will give me the remainder of x dividing by 2. And if the remainder happens to be 0, then I know that the number x is divisible by 2. So this is the expression that represents the number is divisible by 2. So this will return me the output true or false. True as in 1 and false as in 0. True whenever the number is divisible by 2 and false whenever number is not divisible by 2. So this is simply a relational operator equals to. So this is just a single expression. Let's look at the another example wherein you are supposed to write an expression to represent whether the number x is divisible by 3 or not. It's very simple. You have to divide x by 3 and check the remainder. So x mod 3 will give me the remainder. Whenever I divide x by 3, the remainder, okay, and if the remainder is equals to 0, that means the number x is divisible by 3, okay. So this is also a simple expression. Now example C is more interesting and of our interest, because here you are supposed to write down the expression to check if the number is divisible by both 2 as well as 3. So number must be divisible by both 2 as well as 3. So there are two conditions here. One condition or one expression representing number divisible by 2, another expression representing number divisible by 3. We already have noted down the expression for number divisible by 2. The expression is x mod 2 equals 0. This is one of the expression, and I have one more expression, that is number is divisible by 3. The expression is this one, x mod 3 equals 0. Now in example C, we are supposed to combine expression 1, let's say this is expression 1 expr1, and let's say this is expression 2 expr2. We need to combine expression 1 and expression 2 together to get the output of our expression. So in order to combine these multiple expressions, we will be using logical operators. We will be using some operators here in between to combine these two expressions. Let's see what are the operators available. Now we have three kind of logical operators available: logical AND, logical OR, and logical NOT. Logical AND, the symbol is ampersand 2 times. Logical OR is the vertical bar 2 times. And logical NOT is the exclamation mark. Okay. Now let me write a syntax for logical AND. So if we have two expressions, okay, let's say expr1 is my first expression and expr2 is my second expression. So how do I combine them using logical AND? This is how do I combine them: expr1 ampersand expr2. This can be represented using logical AND or AND gate. We have already discussed about logic gates in one of our lectures in section 2. Okay, if you are not clear on this, please go back and watch that video. Now let's move on. Now in this logical AND, the output is true only if both the inputs are true. So if this expression 1 and expression 2, both of them are true, only then the output is true. So this is the last case here in the truth table. Non-zero means non-zero value is true in C. We have already noted down NZ is non-zero. Non-zero value is as good as true value in C, and 0 is false value in C. This is, you have to note down this one. Okay. Now if both the inputs, expression 1 is also not 0, that is it is true. Expression 2 is also non-zero, that is it is true. If both are non-zero, that means if both the inputs are true, the output is true, that is 1. So this is how you do it. In all other cases, the output is false. This is logical AND. Now let's look at logical OR, vertical bar 2 times. So I have represented the truth table for logical OR here as good as OR gate. Okay. Now in logical OR, the output is true if either one of the input is true. So in this case, let me write down the syntax here: expr1 or expr2. This is my syntax for logical OR. It is again a binary operator because it has two operands. Now the final output of this logical OR is true if either this one is true or this one is true. Okay. So if you look at the expression, if any one of them is true, here this one is true, so the output is true. Here this one is true, so the output is true. In the last one, both of them are true, output is true. Okay. If both the inputs are false, in that case the output would be also false. So this is logical OR. Now let's talk about logical NOT. Now let's write down the syntax of logical NOT here. So logical NOT will only take one input. So let's say the input is expr1. This is the expression, and I write NOT just prefixing the expression, I write not of expr. So this is as good as your NOT gate. So if the input is 0, the output is 1, and if the input is non-zero, then output is 0, that is false. Okay, this is how your logical NOT works. Now the important point to note in logical operators are these arguments or the operands of logical operator itself is an expression. Okay, now let's try to understand this in more details by looking at some of the examples. In this example, you are supposed to write an expression to represent that number is divisible by both 2 and 3. So here we have two expressions. One expression will represent whether the number is divisible by 2, and another expression will represent whether the number is divisible by 3. Now I need to combine these expressions together. So I will be using logical operator. So how do I write an expression that number is divisible by 2? If number is x, x mod 2 equals 0 will represent whether the number is divisible by 2. Okay, now how do I write an expression to represent number is divisible by 3? If x is a number, I write x mod 3, I divide x by 3 and check the remainder. If the remainder is equals to 0, that means number is divisible by 3. So these are two expressions. Let me say that this one is expression 1 and this one is my second expression, expression 2. Now, how do I combine these expressions together? My final output should be, number should be divisible by both 2 and 3. Okay, so in that case, if it is divisible by 2 as well as 3, that means both of them need to be true in order to get the correct output. So I have to use logical AND here. So I use ampersand two times. Now let's look at this example wherein I have x as 4. If x is 4, let's see what happens. If x is 4, the first expression will evaluate to what? 4 is divisible by 2. So this is true. Right, this is true. So true is treated as 1, and the second expression, this is logical AND, and the second expression will evaluate to 4 is not divisible by 3, so this is false, 1 and 0. So this is 1, which is a non-zero value, and 0, the output is 0. Right, so the final output is 0. That means the number is not divisible by, number 4 is not divisible by both 2 and 3. It is only divisible by 2, but it is not divisible by 3. By both it is not divisible, so the output is false. Let's try with one more example wherein x is 9. So if x is 9, let's see what happens. Is 9 divisible by 2? No, 9 is not divisible by 2, so the output here is false for the first expression, logical AND. Is 9 divisible by 3? Yes, 9 is divisible by 3, so this is 1. Okay, and if you just look at the truth table, one of them is false, so the output is also false. Okay, that is 0. Now that means it is not divisible. 9 is not divisible by both 2 and 3. Okay, it is only divisible by 3. Now in this case, in C, this expression is not evaluated at all in case whenever x is 9. Because whenever x is 9, first of all, this one is evaluated, expression 1 is evaluated, and we have got the answer as 0, that means false. Now, whatever may be the right hand operand of ampersand here, ampersand, that is logical AND, whatever may be here at the right hand side, this one, it does not matter. If the left hand side is false, I am guaranteed that my output will be false, right? If left hand is false, see, if this is false, whatever may be the right hand side value, answer is always false. Okay, so therefore C will skip evaluating this second expression, expression 2 in this case, because the first expression itself is false. This is how logical AND works, and finally the output is false because it is not divisible by both 2 and 3. That is, 9 is not divisible by both 2 and 3. Okay, now let's look at the final example for this one. Let's say x is equals to 6. So whenever x is 6, what happens is 6 is divisible by 2, that is true, and 6 is also divisible by 3, that is also true. So I'll get the output as true, that is 1. If both of them are true, the output is true, so it is 1. So if it is 6, if the input is 6, the output is 1 or true, because 6 is divisible by both 2 as well as 3. So this is how logical AND works. Now let's move to the next example. You are supposed to check if the number is divisible by either one of them. So either, whenever you get this word either, you have to use logical OR. Okay, so the very simple first expression, x mod 2 equals 0, okay, or x mod 3 equals 0. The first expression is to check if the number is divisible by 2. Second is to check if the number is divisible by 3. Okay, now if I give any input, let's say if I give x equals to 9 as in previous case, okay, if I give x 9, the first one is what? 9 is not divisible by 2, right? So this is false. Or 9 is divisible by 3, so this is true. Whatever it is, false or true is true. So we say that 9 is divisible by either 2 or 3. The output is true because it is divisible by 3. Okay, now let's try with x equals to 4. If x equals to 4, what happens is 4 is divisible by 2. That is correct. Okay, so this is 1. Now, whenever in logical OR first operand is 1, whenever in logical OR first operand is 1, see this is 1, this is true. Whatever may be the second operand, it does not matter, output is always true. Okay, so in logical OR, if the first operand evaluates to true, second operand will not be evaluated. So in this case, this will not be evaluated. Second operand will not be evaluated, and directly the output is given to be 1. Okay, so this is how it works. Now let's look at the another example. Now this is the final example wherein you are supposed to decide if the number is not divisible by 2. First of all, let's see how do I write an expression that a number is divisible by 2. It's very simple. I write x, let's say number is x mod 2 equals 0. So this expression will let us know that if number is divisible by 2. It is divisible by 2 if the output is true, and it is not divisible by 2 if the output is false. Okay, now finally I need to check if it is not divisible by 2. So what I do is I just write not operator here, logical not. Okay, not of this. Now this is my expression to check if number is not divisible by this is divisible by 2. Okay, now let's take some example. If x is, let's say, 16, what happens is 16 mod 2 equals 0. Okay, this is the expression, not of this one. So this is not of, what is 16 mod 2 equals 0? This is true or false? 16 mod 2 is 0 because 16 is divisible by 2, equals 0. So this is true, right? So this is not of true. Not of true is what? What is the complement of true? It is false. So in this case, the output is 0. Because 16 is not divisible by 2 is a false statement. Okay. Now if I try with any odd number, let's say I write 5. What happens is 5 mod 2. Whenever x is 5, 5 mod 2 is 1. So 1 equals 0 is false. So not of false is true. That means whenever x is 5, I say that 5 is not divisible by 2 is a true statement. Therefore the output is true, and it will display 1 instead of true. This is how logical AND, logical OR and logical NOT works. Now let's try to write a program and demonstrate this further. Now I've already created this program called as logical.c, and here we are going to demonstrate how logical operator works in more details. Now let's look at the first example. Example 1 is to write an expression to check if an input character is uppercase. Uppercase as in capital A, capital B up to capital Z. Now first thing first, I'll have to have one character variable ch that is defined here. Okay, and I take the input from the user, the character input from the user in line number 15. The output of my logical operator I'll be storing in the variable ans. Now I need to write an expression for ans. Now before we write our expression, we need to note down that each character is internally represented as a ASCII number, as a ASCII decimal number. So ASCII code for A is 65, ASCII code for capital B is 66, and similarly ASCII code for Z is 90. Okay, they are in the sequence from 65 to 90. These ASCII codes are reserved for capital letters or uppercase. Now it's very simple. I can write an expression here. So my character must be greater than equals to A. So if I write capital A here, so this is a valid expression. I've used relational greater than equals to because each character is internally represented as a number. So this expression is as good as comparing two numbers. Okay, so it is comparing if the ASCII of the input character ch is greater than equals to 65. Okay, and my character, the ASCII of the incoming character must be less than equals to ASCII of Z. Okay, capital Z. I could write in place of capital Z, I could also write 90. That will also be a valid statement. Okay, now here I'll use logical AND because I need to combine this together. Both of these needs to be true in order to catch hold of the uppercase characters. Okay, so I'll be storing the answer in the variable ans, and let me display the answer here. Okay, and let's see how it works. And let me enter the character. Let the character be D. Answer is 1 because D is uppercase. G uppercase is 1. R uppercase is 1. If I give R lowercase, answer is 0 because lowercase is not uppercase, obviously. This is 0 again because I have given the lowercase y. Okay, any uppercase character you give, the output is 1. Okay, this works fine. This is logical AND. Okay, now let's look at example number 2. In example number 2, you are supposed to write an expression to check if an input character is vowel or not. Okay, we know that A, E, I, O, U are vowels. So let's restrict this program only to lowercase a, e, I, o, u. Even uppercase a, e, I, o, u is also a vowel. Okay. Now, first of all, yeah, this character is declared, variable is declared ch. I declare this ans variable to store my answer. Okay. And I've input my character here. And now let me write the expression here at line number 27, answer. So I need to check. It can be either one of these. A, E, I, O or U. Either one of these is a vowel, right? So I can write my character should be equals to A. I use logical OR here. Okay. Character should be equals to E. Character should be equals to I. Okay. Similarly, character should be equals to O. Similarly, finally, the character should be equals to U. Okay. So I can put this entire thing in a bracket also. There is no problem. Now if this is true, that means if the character is either A, E, I, O or U, the output would be true. Therefore, answer would be 1. If it is vowel, otherwise the answer would be 0. Let's try to compile this code. Enter your character. Let's say A. Answer is 1 because A is vowel. If I give R, answer is 0 because R is not vowel. U, answer is 1. Okay. If I give I, what happens is answer is 1. Okay, because first it will check this one. This is false. I is not A. It will check this one. I is not E. False. Right. Then it will check this one. I is equals to I. So this is true. Therefore, the output is also true. Okay. Therefore, I is a vowel. So this is how logical OR works. Now let's look at our final example. Example number 3. To write an expression to check if an input character is a consonant. Now consonant are the alphabets that is not a vowel. Okay. Let's say B is a consonant. C is a consonant. Anything apart from A, E, I, O, U are consonant. Now we already know the expression for writing the vowel. Okay, this is the expression for writing the vowel, for checking if the character is vowel. Now it is a consonant is something complement of vowel, right? Something opposite of vowel. So if I write logical not here, I think it should work fine for us. Okay, let's see how it works. If I enter the character C, now the output is true because C is a consonant. B is a consonant. Okay, and let's give E. E is not a consonant. E is a vowel, so output should be 0. So output is 0. So this is how it works. Okay, so in this program we have learned how to demonstrate logical AND, logical OR and logical NOT. So that's all in this lecture. I hope you have learned how logical operator works. Stay tuned.